Hello. Welcome to class today. This is Alman Stukel, not in the classroom, here to give you just some brief video notes that'll talk about some of the stuff that we need to do today. Just so you all know, we're doing some of the 7.2 notes. Specifically, we're going to be looking at the 7.2 notes on wave interference and the 7.2 notes on the wave properties, the 5 properties all waves have today. This is page 10 in the packet, followed by page 11. That is strictly where we are going to be doing stuff today. So, let's talk about the 5 properties of waves. Basically, all waves share 5 properties that every single type of wave will present in at least some sort of way. So, what are these 5 properties of waves? There are 5 of them, as the 5 properties of waves insinuates. Rectilinear propagation, diffraction, reflection, refraction, and interference. Let's start with interference and talk about it. So we're going to be on page 10 to do so, and the first thing we are going to do is do a sort of demo. There are 2 different types of interference. There is constructive interference where 2 waves build on top of each other to make something greater, and then there is destructive interference where 2 waves destroy each other, meaningfully break each other down. Let's check in and see what happens to these things. We're going to do a few little demos for this. We're going to say, first things first, send 2 waves that are both above the line, right at each other, and we're going to see what happens when these 2 waves meet. Here we are. Let's do this here. So, we have a wave right here, we have a wave right here. Both of these 2 waves, if I let them go, will continue to go towards each other. I want you, at this moment, to, in a second, pause this video, and then turn to your partner and tell them what you think will happen when these 2 waves eventually meet with each other. Okay, so pause the video. Okay, good. Hopefully you did that. Now, you have all your predictions, you have them locked in, you all know what your predictions are, and will keep each other honest with this? Okay, cool. Let's see what happens. Look at that then. As you can notice here, the 2 waves have built up on top of each other and created a larger wave. After we continue this for a little bit, note how they re-break down and just continue as their regular wave selves. If we speed this up a little bit, we can see on the bottom the same thing happens. The 2 waves build to make a larger trough, or they build to make a larger crest, and then they just continue straight through each other as if nothing happened. We can speed this up as much as we want and get as is. So just be aware, when you have 2 waves and they are both a crest or both a trough, they will meaningfully break each other down together and create something larger than themselves. In other words, we can write next to this constructive right here. Let's do crest overlaps with crest, or trough overlaps with trough. And again, this is constructive. It builds on top of each other, one and another. Okay, we're good with that? Okay, so that was constructive interference. Let's now take a look at destructive interference. So the same thing, just now with a slight twist. I'm going to flip this off, and go here. So here we have a wave that is a crest here and a trough here. When we go forward, they will go towards each other like this. I want you, together with whoever's near you, to predict what's going to happen when these two waves overlap with each other. You should pause the video and do that right now, okay? Okay, hopefully you paused the video. Hopefully you chatted with your partner. Hopefully you've decided what precisely is going to happen and have locked that prediction in. Okay, ready? Here it comes, here it comes. Note how the waves, when they are directly overlapping with each other, completely destroy each other before, as with the last one, continuing on through. If we speed this up a little bit, this one's a crest, this one's a trough, they again destroy each other for a little bit. They get closer, 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 and then destroy each other before flipping and continuing going on their way. So just keep this in mind as we're going through this. This is what destructive interference looks like. This is what your waves are going to look like when they are breaking each other down. In other words, when we have our destructive interference, this is a crest and trough overlapping. And it destroys the waves. Note how after a wave is constructively interfering or destructively interfering, it will always return to just moving as it did before. So when we have here, when we say have these two waves meeting, the two waves meet, they create a gigawave, like so. Make big wave. You could even say construct big wave, if we wanted to be facetious. And then afterwards, they just continue as if nothing happened to them. Just continuing on their way. Past, past. Continue like nothing happened. They passed right through each other. And they only interfered when they were in the same place at the same time. Same with destructive interference. When we had destructive interference here and here, while the waves met, they destroyed each other. Right there. And then after they met, they just continued on their way. Ooh. Continue that way, continue that way. Continue like nothing happened. Oh, I didn't write that. No. Here we go. There we go. So yeah. So again, waves are going to interfere like this. This continuing like nothing happened is a really important part to this. And this is a really important part because this is how we reconcile this with waves being the movement of energy and the fact that energy needs to be conserved. Let's recall that energy is always conserved. Energy cannot be created or destroyed. Energy can't be created or destroyed. The wave that's traveling, wavity, 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 is a movement of that energy. If we have the wave as the movement of energy and the amplitude of the wave as that energy, well, the amplitude has to represent the energy and cannot be created or destroyed. That makes this kind of weird because note how the waves destroy each other in this specific space. But note how the information is still recorded. It will continue on. Energy is still conserved. It wasn't created or destroyed. It was just counteracting another energy. So when you have constructive interference, you have energy working together with other energy. And when you have destructive interference, you have energy counteracting other energy. And recall, this only happens when these two waves are in the same place at the same time. Once they stop being in that same place at a different time, well, the waves continue on like nothing happened. They are not affected by each other when they're in different places. So just keep that in mind. That's how we're going to do this. Okay? Let's flip over to the other page, and we're going to talk about the different properties that all waves have. The 5 properties of waves. Let's start out with the first one, rectilinear propagation. Rectilinear propagation sounds very complicated. I don't know why. It is the easiest of these. It is the fact that all waves move in straight lines. That's all this property is. It's just saying that waves will move straight unless something else is forcing them not to. In this specific case, you can take the light coming from Mr. Bucky Badger here. The light coming from Mr. Bucky Badger will reach this person because there's a straight line that connects Bucky Badger to this person. In this case, the light from Mr. Bucky Badger will hit right here, and the person will not be able to see Mr. Bucky Badger as the light gets stuck somewhere on this wall. As any light coming in from here can only hit about here before stopping. It can't go straight. The person isn't here. They can't see. So just be aware. Rectilinear propagation. All waves, light, sound, whatever it be, will travel in straight lines. Now, I say this, and this is true, but there are some exceptions to this. So we're going to put 3 little asterisks next to this, 3 little stars, each of which is an exception. And then we're going to flip to the next property of wave, diffraction. And this is one of those little stars, the first one of those little stars. This says that waves of any sort will bend around corners. So whenever we have waves coming into a corner, say the waves coming through here, they pop right out over here, and they're going. Note how they passed a corner here and here. Waves don't really let that stand. Waves will always bend a little bit around that corner. They will bend to extend out around that corner and these waves will always bend a certain amount. So note how they don't bend fully around the corner, but they're going to bend a bit around the corner. Here, let me just draw all this in. There. So there's a certain angle that they will bend a bit. The bigger the wave is, compared to the corner it's bending around, the more it will bend. So let's go back to this example, right? The light from Bucky will bend a little bit around this corner, but it won't bend enough for the girl to see, as light has teensy tiny waves that are so small that they bend very, very little. Whereas sound, for example, is something that bends pretty well around corners. One of you could say, be standing out in the hallway and shout, and even though no one else could see you out in the hallway, we could all hear you as your voice would bend around the corner that is the door for us all to hear. We can demo that next class. That'll be fun. So that's the first reason why why any wave might not travel in a straight line. Let's go to the second. The second reason that light will not travel in a straight line, the second little asterisk, is reflection. Reflection is the fact that waves will bounce off of surfaces. When you have any sort of wave that's coming in and in to a place, like so, it will bounce off. And it'll go in a different direction. It will fly off of said wave. Reflection is something we're all kind of familiar with, right? Echoes. That was in your daily question today, right? An echo is just the sound wave bouncing off of a wall and bouncing back to you. You all can see right now, me, other people around you, all that is the light from those people bouncing off of those people and going into your eyes, right? This camera right here can see me because the light right up there is shining light on me, and that light is bouncing right into the camera. That's how the camera sees me. That's how it's recording me right now. We have some vocabulary words around reflection we want to be aware of. The incident ray, reflected ray, and normal line. Ray is just a fancy name for a wave. The incident ray is the ray coming towards the surface. The reflected ray is the wave after being reflected. And the normal line, here, let's point to here, right? This is the incident ray. This is the reflected ray. Oh, there we go. And then finally, you see this line right here? This is our normal line. Our normal line is this dotted line here, and it's normal because it forms a right angle to the surface. It is a line perpendicular to the surface, reflecting the wave. So you can think of this normal line as any line perpendicular to the surface that is reflecting the ray. This normal line is important because the angle that we send our ray in with, the angle of the incident ray, in other words, is going to be equal to the angle that the reflected ray is coming out as. All reflection will occur going in at one angle and coming out the same angle. It's symmetrical. Whew. Crazy. Okay. Let's move to talk about the next one. Oh, by the way, if you need to finish taking these notes, always feel free to pause the video and pause it on specific portions to take down the notes. I'm kind of going at a pace here, but you can make it your own pace if you need. Finally, we have reflection or refraction. This is our last little asterisk. It's different than reflection. Reflection and refraction are two different things. They're very similar, though. Refraction is the fact that all waves will bend when they change medium. Remember, medium This word, medium, is the substance our wave is traveling through. So whenever a wave changes what substance it's traveling through, it will bend a bit. The most classic example of this is when you dip your finger into a glass of water. You dip your finger into a glass of water, and you can see that your finger is displaced a little bit from where you want it to be, from where you think it should be. That's because the light coming from your finger is bending as it's changing, going through the water to the glass and then to the air. That change in medium bends where the light is coming from, the straight angle it's coming from, meaning that you think it's coming from here when really it's coming from there. The best example we can take for this is, say, drawing a fish. Let's take it in this and draw a fish real quick. This is a fish. I hope everyone's okay with that. I'm going to take this fish. I'm going to draw the surface of the water up here, like this. And here's you, standing on the surface of the water and observing this fish. The light coming from this fish is going to come up, 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 till it hits the surface of the water. And then, when it hits the surface of the water, it'll bend. Like so. Right? So when we are looking at this fish, we think the fish is over here, because that's a straight line from where it's coming from. And we, as humans, know that waves, like light, travel in straight lines. So we think fish is actually fish is. It's a difference in where we think the fish is and where the fish actually is, based on where the light is coming from. So just be aware on that, how we can kind of see this change in the direction any wave has. Light, most specifically. Light is the easiest one to see this in. We'll talk a little bit about where this comes into sound, but light's the main one here. But yeah, this is the main kind of place where we can see this as a thing. Finally, we can talk about interference. Interference is the last thing that we'll talk about, because it's the first thing we talked about. We have the two different types of interference, constructive interference and destructive interference. When we have constructive interference, note how we have a crest lined up with a crest, a trough lined up with a trough, crest, crest, trough, trough, crest, crest, trough, trough. The two crests here will make a big crest. The two troughs here will make a big trough, big crest, big trough, big crest, big trough, big crest, big trough, big crest, big trough. They just make it bigger. That's all they do. Let's formally define interference. It's that waves will affect each other when they are in the same place at the same time. So whenever waves are in the same place at the same time, that is when you can say they are interfering with each other. So when this wave here is in the same place that this wave is at here, they will build on each other. They will constructively interfere, making something bigger than either of them. In this one, we have a crest lined up with a trough, a crest and a trough, a crest and a trough, right? These will fully cancel each other out. They will fully destroy each other, as a crest of the equal size as this trough will fully cancel each other out, making full destructive interference. Okay, so these are the 5 properties of waves. That's all we're going to touch on for this class. Next class we'll talk about sound, specifically some more things on sound, And then finally, how sound shows us all of these 5 properties of waves. For the rest of class, you have the formative assessment. Just follow whatever is up on the slides and you should be good. Thank you all for joining me for weird virtual class today that I pre-recorded. Hope you have a great rest of your day, and I'll see you on Friday. Okay, bye-bye.